Hello, everyone. Welcome back to the Rev Games Academy. And today we're stepping into the exciting world of Unity physics. We'll be exploring two fundamental components, rigid bodies and colliders, the key ingredients for bringing realistic motion and collisions to life in your games. Ready to get started? Let's dive right in. First, let's talk about Unity physics. Now, you might be wondering, how do games make objects fall, bounce, or react when they hit something? Well, that's where Unity physics comes in. Think of Unity physics as the engine that makes everything in your game act like it's in the real world. If you drop a ball, it falls, bounces, or rolls, depending on how you set things up. And this is all handled by Unity's physics system, which simulates real-world behaviors like gravity, collisions, and forces. And also, Unity uses a super cool engine called PhysX to do all the hard work behind the scenes. It's a real-time physics engine that calculates how things move, bounce, slide, and react to different forces. Okay, now next up, let's talk about rigid body and colliders. A rigid body is a special Unity component that brings life to your game objects by giving them physical properties like mass, drag, and the ability to respond to forces. This means your object no longer just sits idle in the scene. It can move, fall, roll, and even bounce around, following the rules of physics. Hey, now let's move to Unity Editor and checks how the rigid body can work into the object. First, create a cube in our scene, so click the plus icon and create cube. Then go to the inspector, click Add Component, type rigid body. You'll see two options, rigid body and rigid body 2D, and the rigid body 2D is used for 2D objects in Unity. Here we're working with a 3D object, so we'll select rigid body for this tutorial. And adding a rigid body instantly applies physics to your object. Okay, let's hit play and watch what happens. See that? The cube starts falling. That's because gravity is applied by default. This motion is called free fall, an object moving under the influence of gravity alone. And it's pretty cool, right? Let's take it a step further. In the rigid body component, you'll see a checkbox for use gravity. Uncheck that and then hit play again. Notice something different? That's right, the cube does not fall this time because gravity is now turned off. Before we wrap up, let's quickly go over a few other settings you should know about. First, mass. This controls how heavy the object feels in physics calculations. Drag and angular drag determine how much resistance the cube faces when moving or rotating, and the is kinematic. If you enable this, the cube ignores physics and can only be moved through code. So there you have it. Now try experimenting with these settings on your own and see how the cube behaves under different conditions. You're starting to get a solid understanding of rigid body physics. Now, let's talk about the collider. A collider is like an invisible force field around your object. It defines the shape of your object for detecting collisions with other objects in your scene. While the rigid body makes your object move and react to forces, the collider is responsible for telling Unity when two objects are touching or hitting each other. Without a collider, objects would just pass through each other in the game, which would be pretty weird, right? Now, there are a few different types of colliders depending on the shape of the object you're working with. Let's go over them quickly. First, the box collider defines a cube-shaped collision area around an object. It's great for square and rectangle-shaped objects like wooden box, walls, and etc. The second type is the sphere collider. It creates a spherical collision area around an object, perfect for handling round or circular shapes. In 2D games, you can use the Circle Collider 2D, which is specifically designed for circular objects in 2D environments. This type of collider is great for objects like a bouncing ball, planets, or any other circular shape in your game. And third, capsule collider. This is ideal for capsule-shaped objects like a character or a bottle. The final one is mesh collider. Is this used for complex or custom 3D shapes if your object doesn't fit into any of the standard shapes? It works best for car environments. All right, let's jump into Unity and see how colliders actually work in action. And let's get started with some practical collider work. First, create a plane object in your scene and place the plane just below the cube to set up the foundation for our physics interaction. When you check the inspector window, you'll notice that a mesh collider is already added to the plane. This is Unity's way of providing the plane with a basic collision shape so it can interact with other objects in the scene. You can simply disable the mesh render component and see how the mesh collider perfectly wraps around the flat mesh of the plane. This makes it instantly ready for physics interaction. Now, let's bring in a cube object for testing. Select the cube, and you'll see a box collider automatically attached in the inspector. If you ever need to adjust the size of this collider to better fit your object, just click on Edit Collider. This lets you resize or reposition the collider as needed to match your object's shape. However, in this case, there's no need to adjust anything because the box collider fits the cube perfectly by default. But it's good to know this option is there whenever you need it. So let's use Control-Z to back to normal state. Now it's time to test it out. Let's hit play and observe how the cube stands on the plane. Yep, the cube should rest on the plane, and let's say thanks to the colliders. While we're at it, let's take a look at the isTrigger checkbox in the collider component. Enable it, then run the game again. What happens now? You might notice that the cube falls right through the plane. That's because enabling isTrigger turns off physical collision detection, meaning the cube no longer interacts with the plane physically. Try it out yourself and see how the isTrigger option changes the way your objects interact with others. It's a great way to explore collision behavior. All right, the video is going to be awesome, and that's it for now. Now you know how to add realistic physics using Rigidbody and colliders in Unity. I encourage you to test it out and experiment with the settings to see how it affects your objects. And if you run into any questions or cool discoveries, let me know in the comments. I'd love to hear from you. In the next video, we're going to dive into gravity and falling objects. So don't forget to like, share, and subscribe for more Unity tips and tutorials. See you in the next video. Bye.